Alright, what's up guys? In this video I'm going to pick up with some calculus here, and we're going to do some more trigonometric integration. This is going to be a definite integral, and this is going to be example number 5, I believe. So this is what we're going to work on to begin today's videos. Okay, well, so you got this definite integral from 0 to the power of 2. We got secant to the fourth of t over 2, and we need to integrate that with respect to t. So you can just start with a u substitution and kind of see where the integral takes you from there. Obvious selection for u here is t over 2. And then du would be the derivative of that, which is just 1/2 multiplied by dt. And then we get 2 du is equal to dt. So since 2 is a constant, we can bring it out front. And what we'll end up with is the antiderivative of secant to the fourth of u du. Now we need to change the limits. So if u is t over 2, all we have to do is substitute in a 0 and then substitute in a pi over 2. Okay, so substituting in 0 is just going to give us a 0. And if we substitute in pi over 2, we'll have pi over 2 divided by 2, which is pi over 4. So this would be from 0 to pi over 4 now. And we've changed the limits there. Alright, so now we just need to evaluate the integral 2 times the definite integral from 0 to pi over 4. We got secant to the fourth of u du. So the best thing to do here is just to rewrite secant to the fourth. We've done this before. You can even use trigonometric reduction formulas in some cases as well, which we've talked about in the past. So secant to the fourth of u, that's the same thing as secant squared of u multiplied by another secant squared of u. And we also know that secant squared of u can be rewritten as 1 minus tangent squared of u. So we got our 2, we got our integral from 0 to pi over 4. And then what we got is secant squared of u multiplied by 1 minus tangent squared of u du. Now when you look at it, it looked like we made the integral worse, but we actually made it a lot better, because now we can do another substitution. And anytime you got to do another substitution, you want to try to choose a different variable. You don't want to use the same one. It doesn't matter which variable you choose to do your second substitution, as long as you're choosing something different. Most people choose v. I like to go a little unconventional and use w. Again, it doesn't matter. And so the next substitution I'm going to do is tangent of u. And the reason why I want to do that is because I know the derivative tangent of u is secant squared of u. We got a secant squared of u in the integrand, so we know it's going to cancel it out for us, which is great. So that's the purpose of picking tangent squared of u to be, or not tangent squared of u, but tangent of u. Excuse me, if I said tangent squared of u, I meant tangent of u. And again, you get secant squared of u du, and you get 1 over secant squared of u dw is equal to du. And what happens is our secant squared will cancel out. So we got our 2. We got to change the limits one more time. And what we'll end up having is 1 plus w squared dw Now we change the limits. So remember that W was tangent of U, so all you have to do to change them is plug in the 0 and then plug in the power 4. Okay, so tangent of 0, that's what we substitute in. Well, that's just 0, and then remember tangent of power 4 is 1, so this would be from 0 to 1. And really what this is 2 times the integral from 0 to 1 dw, plus the integral from 0 to 1 w squared dw, which just gives us 1, and this gives us 1/3 because we'll apply the product rule, the power rule in that case. So really what you're looking at is 2 multiplied by 1 plus 1/3. Remember, 1 plus 1/3 is 4/3. So this would be 2 times 4 over 3, which gives us 8 over 3, which can't be reduced. And that would be your answer. So your final answer for this trig integral here is 8/3. And that's how you do it. So it was the integral from 0 to the power 2, and it was secant to the 4th of t over 2 integrated with respect to t, and the answer is 8 over 3. That's your solution. Alright, so let me know if you got any questions about this. I'll be more than happy to explain it further, but that's how you solve it. Alright guys, y'all take care. I'll see y'all next time.